All right, so we're gonna do the Death Nut Challenge. I'm wearing gloves because I don't want the stuff on my hands touch my eyes and it burns. So this is level 1. It's a Carolina Reaper and chocolate Ootla pepper. No. Let's see. Woo! That's level 1. It just keeps coming. Haven't even eaten the second one yet. I'm sweating. Oh God. Oh. Next level. Level 3. Heat level medium. Carolina Reaper. Who names these things? 7-pot brain strain? Holy. Gets in like your sinuses. I'm good. Oh, this one's rough. Oh God, guys. Oh.
You got one more.
No, I've got 2 more.
You gotta get on it, bud.
So, the next one is the Death Nut. And it is 2 times Carolina Reaper, a Moruga Scorpion, and then 13 million Scoville pure Capsaicin crystals. Oh, there it is. Oh wow. My face is red. I believe it. I'm like sweating. That's my milk. I'm going to get it. Bye. Have you ever eaten anything really spicy and then you felt that burn in your mouth? Well, if you were to actually take the temperature of your mouth, you'd notice it wasn't actually hot. So what's causing that? It's a molecule known as capsaicin. The capsaicin has 18 carbon atoms, 27 hydrogen atoms, 1 nitrogen atom, and 3 oxygen atoms. So how does that cause a burn? Well, capsaicin has this wonderful shape that it bonds to one of your nerve receptors. It just so happens that that particular nerve receptor is responsible for the feelings of excess heat and physical abrasion. So whenever those receptors are triggered, they send signals to the brain saying, hey, we just got burned or physically abrased. Now capsaicin has the perfect shape to bond to those receptors, and therefore when you eat something with a lot of this molecule in it, your brain gets the signal, hey, our mouth is getting burned and physically abrased. Well, what happens? It thinks there's a very high temperature in your mouth. Turns out there's not, but that's what your brain thinks. So you break out in a sweat to start to cool you off. Your face flushes. As the blood rushes to the outside of your body, to your skin, you turn red. That blood is rushing out to help release heat into the environment to try to cool you off, even though you're actually not getting any hotter. So where does the capsaicin molecule come from? Well, it comes from pepper plants. These plants have developed this molecule as a defense mechanism. Now, if you've studied elementary biology, you might know that some plants take advantage of animals to spread their seeds. Animals will eat what the plants produce and pass the seeds along the way, and that spreads the plant's population area. So why would a plant not want that? Why would it produce this spice, this heat sensation, to stop an animal from eating it? Well, the answer is actually kind of simple. As mammals, we have the receptors that respond to the capsaicin molecules. In birds, though, those same receptors work a little bit differently, and capsaicin actually doesn't affect birds. When a mammal eats peppers, the molars tend to crush the seeds. Well, that doesn't do the plant any good because then the seeds are destroyed. But when a bird eats the pepper, it's got no molars. It swallows the seeds whole and then passes them as it flies along its business. So you may have heard that we measure how spicy a pepper is on something called the Scoville Scale. And you get these ridiculous numbers like 10,000 or 100,000. What does that even mean? Well, the Scoville Scale was invented over a century ago, and here's how it breaks down. If you take 1 milliliter, so a very, very small amount of pepper extract, it's going to be kind of hot. To combat that, to dilute that, you can drink sugar water. So the Scoville Scale is based on how much sugar water is going to drown out the heat. For example, if it takes 100 milliliters of sugar water to cancel out 1 milliliter of pepper extract, the Scoville rating is 100. Pure capsaicin crystals have a Scoville rating of 13 million. That means it takes 13 million milliliters to cancel out 1 milliliter of pure capsaicin extract. Well, what does that translate to? Over 3,400 gallons of sugar water to cancel out the effect of 1 milliliter of pure capsaicin crystal. Since capsaicin is just bonding to nerve receptors, it really doesn't do any harm to the body. What do you mean? Well, your body is going to react as though it's getting burned and physically abrased. Those reactions are what we're going to perceive as damage being done. You're going to have flushing, you're going to have sweating, you're going to have inflammation, you might even vomit. That's your body's reaction trying to get rid of this toxin, trying to get rid of this thing that it knows shouldn't be there. But in reality, the capsaicin isn't doing any harm in the long run. If we eat something that's too spicy, how do we get rid of that? Do I grab a glass of water or a glass of milk? What do I do to help combat that sensation of burning? Well, here's the deal. Water is a polar molecule. It's got one end that's a little positive and one end that's a little negative. Capsaicin is nonpolar. It's electrically neutral. There's a saying in chemistry that like dissolves like. That means polar solutions will dissolve polar compounds. Nonpolar solutions will dissolve nonpolar compounds. But there's no crossover. Think of oil and water. Oil is nonpolar. Water is polar. They don't mix. So if I have a mouthful of capsaicin and I drink water, that's like pouring water on an oil slick. All it's going to do is spread the oil around. It's not actually going to dissolve the capsaicin. It's just going to spread the capsaicin. So now the situation is going to be much worse than it was initially. How then do I actually get rid of this stuff? It turns out milk has some non-polar components to it. It can actually remove the capsaicin from the equation, so that gives you some relief. Your body's still going to react to it, but it won't be as intense. And that's why spicy foods burn so much.
We are the crew. And we're about to do it.
Switch.
This one's getting started. Okay.
Break it in.
A nut for you.
Thank you.
A nut for you. A nut for myself.
Cheers.